Good morning, everybody. Welcome to a session I think everybody has to feel they want to come to because we're after the party and it's, a lot of people are probably feeling a little under the weather here, so I appreciate you coming. Hope you've had a great week. I speak for everybody, I think, when I say it's been great to be back having a live event and be able to meet in person and do things of that nature. My name is Brendan Burish. I'm a principal architect. I work in the field. I'm out of Minneapolis, St. Paul. I've been at Cisco for 26 years. I have been presenting at Cisco Live for a decade in the US, Europe, and Australia, actually. So we are going to cover defense in depth, security for multi-cloud data centers. Probably by this time, you all know that all of our sessions this year are 45 minutes. So we got a busy agenda, and we'll have to hustle through a fair bit of content. This at one time was a 2-hour session in years past. I won't spend a lot of time on this slide. You've seen it repeatedly this week. I think the important thing I want everybody to understand, there's our session ID. The Teams room will be open till June 17th. You're welcome to post questions in there. If for some reason you can't get to the slides, I'll be happy to post them in the Teams room as well. Somebody can just drop a note in there if you'd like. And so, as I said, we have a busy agenda this morning. I want everybody to be clear that, we are going to focus on the kind of ACI anchored fabric here as kind of how we level set the network. And we're going to go into a variety of things that are specific to ACI in terms of how we set policy construction, how we essentially build segmentation, the variety of techniques that we use. We're going to talk about how we introduce L4 through L7 service insertion sorts of techniques. Then we're also going to chat a bit about the extension to the public cloud. And then we're going to make a slight pivot and start talking about secure workload, which some of you may know at one point used to be called a platform known as tetration. And we'll talk about how that complements and augments what we're doing with ACI, and that'll draw us to a close. By all means, if you have questions, please, as we're moving along the way, stop me and ask. If they're lengthy questions, I'll just ask that we maybe take them to the end of the session. You're welcome to come on up. So I think by now, many of you probably know ACI is one of our kind of foundational SDN architectures that the Nexus 9K portfolio supports. It is by definition a leaf spine VXLAN based topology, right? We support standalone as well, but today, for today's purposes, we're going to be discussing or focusing on ACI rather. And what we're going to really focus on initially is kind of the embedded security techniques that we provide. We're also going to get into kind of how we extend some of that to provide micro-segmentation. We'll talk about how we do security automation, specifically around how we anchor in and tie in stitched devices for the purposes of additional security services. And then the last thing that you don't see illustrated on the slide, of course, is we'll talk about secure workload. One thing I want everybody to understand, particularly at the security automation level, is we do support Cisco and third-party platforms. So in that sense, we are vendor neutral here, all right? Now, one of the things about ACI is there has always been kind of this notion of it is an application-centric infrastructure, and that certainly coincides with the name. One of the things I want everybody to understand is there's really two modes for delivering policy in ACI. We have what's called network mode and we have application mode. Most of our customers, when they initially introduce this technology, are going to run in network-centric mode. And what do we mean by network-centric mode? We essentially mean policy gets enumerated in network concepts. VLANs, bridging, forwarding, things of that nature, IP addresses, subnets, things that we're conventionally accustomed to as network teams. We also have this idea that if you want to get much more specific and granular around policy, you can start writing policy structures and application logic. Things like ports and protocols and a web front end versus a database back end. You can mix and match these. It is the exact same foundational technology underneath in terms of how we enumerate policy to the CAM tables. And often, as the slide says, we have customers that start in network-centric mode and then move to application-centric mode as they kind of graduate to understanding policy better. Now, let's talk a little bit about the policy model. This is a build slide, so I'll let this kind of steadily build in here. But we start with a domain, right? Effectively, some sort of name here. And then underneath that domain, we create a VRF. And underneath that, we create something known as a bridge domain, right? And a VRF is the same thing in the sense that what you know a VRF is today, same idea in ACI. Essentially, per tenant, we've got a routing domain anchored to that tenant. The bridge domain, if we correlate it to a lot of the concepts from prior networking technologies, would be mapped to subnet and SVI. And then underneath that, we have something known as endpoint groups, or what we kind of generally abbreviate as EPGs. And EPGs are loosely, essentially analogized to broadcast domains, VLANs, private VLANs, things of that nature. And that's how we lay that out. EPGs, of course, map to where all of the workloads sit in the fabric. Now, the other thing to know about ACI is it is a whitelist policy model. And as a consequence, we come out of the box as a deny all sort of architecture, meaning we won't forward anything unless we know the identity and we have a contract associated with that relationship between these EPGs. And so we're going to essentially create structured policy that suggests you're going to describe what we're going to allow people to do, and there's an implicit deny all around all other activity. We also have this idea that there's got to be a way out of the fabric. And many of you know we have essentially the border gateways that representationally can be attached to the leaf or the spine. And we generally have two ways that border gateways get set up, either in an L2 manner, which would be equivalent to an 802.1q trunk, or in a routed manner. It'd be an L3 routed link. And if we put this all together, this is what this actually looks like in total, the ACI policy model, where you've got a tenant, you've got a respective VRF that maps to that is responsible for all the routing, and then I've got all the individual bridge domains and EPGs and associated workloads, and then I have my exit points for the fabric, either at L2 or L3 respectively. So this is how we create the tenancy model inside of ACI, and this is kind of the most core technology that you need to understand in terms of enablement of this technology and of this SDN architecture. Let's talk a little bit about how we go about building policy. As I said, this is a whitelist policy model. We deny all unless we actually change the default behavior, and we're going to talk about how this works, but essentially no contract, no identity, no communication. That's really the whole idea here. So it operates essentially the opposite of what many of our conventional architectures do, where we assume all communication is allowed until otherwise said as part of a blacklist model. So we've got an opposite sort of model here, much more conducive to higher levels of security. So as I said, between groups, without contracts, there is no communication. Now let's talk about how contracts actually get built here. And we'll just give a very, very simple example. And there's this notion of consumption of contracts and providing contracts. And all of our communications is bidirectional, but we have to contractually stipulate each direction as we build contracts. So in this example, green is going to provide a contract that it's going to expose TCP ports 80 and 443. Blue is going to consume the contract, so those ports are not actually exposed. Now we could obviously write this in the reverse direction, but what this yields is the ability for port 80 to flow from left to right, as you see it illustrated on the slide. And then respectively, port 80, and in this case, we'll illustrate another one, port 8080 are not allowed based on the contractual logic that we've built here. This is obviously an extremely simple example. Contractual logic can be obviously far more sophisticated than this, and we get into a lot of very, very specific details. And this should loosely be analogized to access list construction that you may be accustomed to in kind of our non-SDN architectures. Now, the other thing that ACI allows as part of the contractual operation is the ability to insert additional security services. So one thing I'm clear with everybody on when we talk about ACI, these are L4 stateless contracts. Okay, they operate at L4 and they are stateless in nature. So if you need more granular and more kind of ruggedized security, then oftentimes the compliance and the security teams are going to say, well, the traffic must run through a firewall. Something that is stateful in nature. And stateful, of course, means we have a connection that comes in, we stop the connection, start a second one, and we manage that connection relationship between the two. So as part of a contract, in addition to the access control functions at L4, we can write it such that we steer that traffic to a firewall or to whatever sort of security manipulation device we're going to want to direct that traffic to. Okay, so that's also part of the contract operation here. Not mandatory, but certainly gives us much more rigorous security enablement as we think about kind of complementing the contracts that come with the fabric inherently. Now, I'll give you a chance to read here, but some things that are really important, right? So EPGs have associations to provide and or consume contracts. We talked about that in the last. They can either provide or consume, and they can do both. And this is kind of how we establish directionality. And that talks about this notion of the ability to provide and or consume contracts. They can also support the ability to do that for multiple contracts. So it's not just a single operation, it is multiple in nature. We talked about directionality here, of course, also. The other thing to understand is contracts can be used at a variety of different levels. Remember the policy model that we laid out where we had tenant, we had VRF, we had bridge domains, we had EPGs. You can write contracts at a variety of those levels specifically to explicitly control traffic. And one of the things that's key to understand here is we also require a contract between bridge domains for the control of all the route leaking that goes on, right? Because we said there's typically a different VRF in each case, and this is how we explicitly control how the route forwarding works between those respective constructs in the policy model. Now, as I said at the outset, there is also a way to change the default behavior of our fabric. So today, our fabric comes out of the box as a whitelist policy model, meaning we deny all until contracts stipulate otherwise. There's something known as VRF unenforced mode. You can change the default behavior and move this back to a blacklist model. We do have customers that do start in this model, and then, the difference being, of course, we now, without writing any contracts, can provide a more conventional way that the fabric operates. Now, some of you may look at this and think, okay, this may be a more graceful migration pattern for us because we write all of our policy today in the model on the left-hand side versus this is going to be a little more difficult in the sense that I have to have a solid understanding of how applications behave and how they interact with one another. So understand it can be changed. I don't often advise this because it defeats some of the purpose or some of the value of the fabric, but nevertheless, we give you a knob to enable the ability to do this. Are there any questions about this and kind of what I've covered so far around kind of policy model structures here?
In terms of creating the policies, right, to allow what traffic to pass.
Mm-hmm.
What if we're dealing with TFTP where the cost may be a little bit more dynamic?
So the question was, what do we do about things that are more dynamic in nature like TFTP? So you still have to have an understanding of all the ports and protocols. You can write wildcards, of course, still. So there's ways to not have to write explicit definitions around all the contracts. But if there are dynamic ports, FTP is another example, given it has differing port numbers. You still got to write contractual logic to be able to support that. Now, as I said, there are also a way to support what are called wildcards. And the idea of wildcards, of course, is twofold. We want to simplify situations where you're writing contracts that may be very, very similar in nature. And there's two reasons we want to do that. We don't want to rewrite or write contracts over and over and over that are the exact same. And we also, like any conventional infrastructure, have switching considerations, in the sense that we have CAM tables that hold all of the policy information, and that is a fixed resource. It is an exhaustible resource. As a consequence, we want to pay attention to CAM table exhaustion. Okay, so there are optimization techniques that say I can use things like VZNE. So in the absence of VZNE in this model, I would have to write all 6 of these contracts to create essentially the ability for me to communicate amongst each other. Or I can take one contract and essentially write the equivalent of an any to any and essentially yield the same thing here. So not only is it simpler, but it also consumes far less TCAM table resources. And you're going to sense a theme as we move through the presentation, and in the sense that a lot of these techniques are about simplification of contractual operation, and also how do I preserve that precious CAM table resource or asset such that we don't blow those things out. Now, we also have something known as a preferred group operating principle. And think of this as very similar to private VLANs, for those of you that may or may not have used private VLANs in the past. In the sense that I can create a preferred group, and as you see, that preferred group, I provide free and unrestricted communication between the EPGs sitting in the preferred group. Don't have to write a contract. I just put them in the preferred group, and they can communicate with each other freely across all ports and protocols. What they can't do is communicate with anything outside of that without a contract, because then conventional rules are going to apply here. So we have customers that use this across the entire fabric in the sense that they can create groupings and they can easily provide communication, and then they essentially use all the group relationships to create all their policy between them. Now, the other thing to keep in mind here is, as I said, they can't communicate across those boundaries without contracts, nor can they communicate with an EPG outside, right? And this is back to the original conversation we had about the policy model, that we have the way out of the fabric, an L2 out or an L3 out. And in order for the preferred group to be able to access that, or then to come through that, you've got to have a contract in place to facilitate that level of communication. Now, the other thing I want everybody to understand that's important about ACI, because there's kind of this discussion about, oh, be careful about CAM table resources. We want to preserve those and protect those. We don't want to exhaust those. ACI is also extremely efficient in the sense that we don't write policy anywhere where it is not required. And we also go further than that in the sense that we do not start programming policy until you see some of these things. We have something known as resolution and immediacy, which determines when the download of policy goes to the switch software. And you've got a number of ways you can enable that. You can pre-provision it, you can have it immediate, or you can have it on demand at workload attach. We also have this notion of something called deployment immediacy, which specifies when the policy is configured on the hardware. Right, so as many of you probably may know about ACI, the APIC is our centralized set of controllers where all configuration work is done. However, the fabric operates as a set of individual devices responsible for all of their own forwarding operations. And so this is where this is important to understand. Even though you're authoring and writing policy up here, it is not until one of these two conditions or both of those conditions are met where we actually start taking the trouble of writing things into the switching infrastructure. Yes, sir, you have a question.
I have a question. Can configure all contracts under EPG? If you have a big network with a lot of contracts, how can you manage this in a good way? Because the GUI of the APIC is not very nice to manage that perspective. And I see the ACI as a kind of big firewall or security device.
Right.
So I like to manage that like a firewall kind of way.
Right. So I think the question is, if I have a large network and I have a lot of policy to enumerate, what are some ways I can simplify that, right? So there's a couple answers to that. We clearly generally discourage use of a CLI here. We've got essentially a lot of UI tools as part of the construction of the controller function. With that said, we generally, in your scenario, have customers using third-party automation tools to enable a lot of this. They'll use Ansible or they'll use Terraform or something like that to automate the startup and the batch or bulk configuration of a lot of contracts. We have open programmatic interfaces. We have a lot of Ansible playbooks that are already pre-written and pre-existing out in our GitHub repositories. We've got a Terraform provider here also that allows you to facilitate batch configuration. So generally speaking, the answer is we look to third-party automation tools that are probably already in your DevOps and kind of CI/CD tool chaining to make this a simpler exercise, particularly at large scale.
That's provisioning stuff, but if you have to operate it and from an operational day 2 perspective, you need some tooling to oversee what's programmed.
You're right. And so one thing we're not going to cover in our session today is we have something known as NXOS Dashboard. And NXOS Dashboard is where we do all of our telemetry collection, ingestion, and there's an AI/ML engine that essentially renders visualization of the network and provides a lot of operational troubleshooting and remediation tools. That is a complementary product here where I think a lot of what you're asking would get done, okay? So if you want to come up afterwards, I'm happy to go into a little bit more about what Dashboard does and doesn't do. I mean, APIC provides some provisioning and day 2 tools, but Dashboard is clearly going to be where we provide more of that. Now let's talk about how we microsegment, because microsegmentation is also, a clearly interesting topic to most customers in the sense that I want to be able to write much more explicit policy. And so I've got a number of ways that I can go about doing this. One of the first is something known as EPG isolation. And in a simple manner, we enable EPG isolation. And what this allows me to do is essentially deny communication within the EPG. So the default behavior, of course, is typically everything in the CPG could talk to one another. In this case, I'm going to deny that. You see that via the red kind of arrows here. I'm denying communication within the EPG. That is handled as a result of this implicit deny all. And then I'm going to write a contract that actually facilitates the ability for me to communicate between EPG A and B. So it's essentially a zoning technique, if you want to think of it that way. And it's an easy way to delineate further how I enumerate policy and preserve CAM table resources as we talked about. Now, if I want to take that a little further, I actually support something known as EPG or intra-EPG contracts. Okay, so in the past, or the prior example, it's an all or nothing proposition. I turn it on and I deny all communication between the respective widgets in an EPG. Maybe I want that to be a little bit more granular, specific to say, I want to deny most communication within the EPG, but I want to permit a couple specific sockets or ports or protocols. Maybe I've got an RDP jump host as an example or something like that. I can then take this a step further and actually write a contract. And so as a consequence, we find more customers find this appealing in the sense that I have greater levels of control versus the prior example is pretty much a light switch. It's either on or it's off. This essentially allows me the equivalent of a dimmer, for the purpose of a crude example in the sense that it allows me a lot more control in terms of how traffic moves between the respective devices inside of the EPG. Another thing we provide here is something known as contract inheritance. And contract inheritance is this idea that I can write contracts one time, I create a parent and child relationship, and as a result of screening, I can essentially say, hey, I have a match on a specific attribute that I have written. In this case, attribute X is what we're calling that. And then at that point, it can pick up a set of pre-existing contracts that are already written. Now, you could obviously take the other approach and write these individually and explicitly as a result. But again, back to kind of our theme here. This simplifies and reduces the amount of contractual relationships I have to write, and it preserves CAM table types of resources. I'll let this build in. We also have this concept of what's known as a micro EPG. Okay, and a micro EPG essentially allows me to take attributes, in many cases VM attributes, and further divide a EPG relationship like you see in the EPG green illustration here. So I'll let this build in. So based on a UEPG, which is a micro-segmented definition, I'm going to use MAC or IP address. I can do either or, and I'm going to essentially filter or move them into a micro-segmented EPG. Okay, so in this case, I'm going to move bare metal 1 into this my database, and I'm going to move the VM01 into a quarantine. And I'm going to do that, in this case, based on a VM name, because I have ESXi information that I can act upon. And so by simply using attributes to filter and move things into essentially a smaller set of contained relationships, I create an additional layer of security known as micro-segmented EPGs. Now, for those of you that are, have advanced past just VM-based workload enablement, we also support the same sort of micro-segmentation for Kubernetes-based workloads. And we're not going to go into a long, essentially, explanation on Kubernetes, but the point here is I've got a variety of techniques that allow me to essentially divide off my Kubernetes-based workloads into either cluster isolation, namespace isolation, or deployment isolation. And you see where the contracts get written here and how that further level of control essentially can provide a very, very granular in-cluster level of security for Kubernetes-based workloads. You have a question, sir? It is. So the question was, is the APIC controller managing Kubernetes? We have a VMM plugin for Kubernetes. So there's a CNI plugin that allows us to manage Kubernetes workloads. We have an OpenShift plugin. I believe we support Rancher now. So there's a variety of these that we support via the VMM integration function. Yes, sir. They do. So the question was, do they go to the level of host to host or app to app? So they can do app to app. So depending on the explicit nature of how you want to write the content, true microsegmentation. Exactly. Now, one of the other things that we've introduced recently is something known as ESGs. And I'm going to let this slide build in. But remember back to the policy model we talked about at the outset. And we essentially map this notion of a tenant to a bridge domain and EPGs, right? And one of the things that we got a lot of feedback from our customers on is we would like detachable policy in the sense that I don't want the policy to follow the network path structures. So how do I detach that? And essentially you see we've introduced something known as an ESG. And that allows me to run security groups across bridge domains. So in all the other examples, you'll notice that the bridge domain is essentially the function that acts as the network delimiting factor in how I can or can't write policy. With an ESG-based nomenclature, I now have the ability to start writing policy between these things known as ESGs, okay? Endpoint security groups. So flexible security grouping, policy detached from what we're doing at the network level. So this tends to make our security teams a little more comfortable around how policy gets enumerated inside of ACI. So as I talked about, a concept that is across bridge domains, okay? We configure the EP selector to classify endpoints into an ESG, and essentially an EPG becomes merely a VLAN path binding component. Now, where I think this really comes together is via this next example. So in this next example, if I were writing policy in conventional structures, I would have to write a contract for EPG 1 to talk to EPG 2, 3 to talk to 4 is an any to any, and then I have to have 1 to 3, 1 to 4, 2 to 3, 2 to 4. 6 contracts, right, for me to provide communication here. And this is a simple n times n minus 1 over 2 problem. If I use ESGs, I can simply create this additional layer of granulation or granularity, and now I write one contract between the blue and the green, and I yield this. So again, a much simpler and detachable way for me to enumerate and write policy. All right, these came in 5.0, and on a growing basis, we're seeing more and more support across our portfolio for the ESG structure. Now, let's make a quick pivot. We're not going to spend a lot of time on this, but I do want to get into at least some discussion about integration of L4 through L7 services. Everything we talked about up until now is native policy inside the fabric. L4 stateless policy. As I said at the outset, we may well have situations where we need stateful security. And we've got 3 modes that we actually allow facilitation of integration into these L4 through L7 service stitching devices. We first came out with this thing called service policy mode. It had a device package integration which tightly coupled things together. It didn't prove to be wildly popular because it meant that I was granting operational control to the network teams to configure things like firewalls and load balancers. And most of our customers are fairly siloed in terms of operational teams. As a consequence, we now generally support 2 modes here. We support what's known as network policy mode. Essentially, this means the fabric will, at the policy instructions, send the traffic to a firewall, and then we just wait for the firewall to do what it's going to do and send it back to the fabric, and then we move on with the additional forwarding logic. We also have a way to more tightly integrate this around the notion of, instead of directly taking control of the firewall, I will have ACI talk to the service cluster manager, i.e. the management device. So let's use Palo Alto as an example, pretty widely deployed platform. Panorama is their management system. I could have APIC talk to Panorama, plumb policy, and then I still kind of create my lanes of responsibility or preserve them, but yet I can still have a tightly integrated service stitching function. Now, how we actually enumerate this or how this looks, and I illustrate this because when the fabric first came out many years ago, our service stitching was a little klutzy in the sense that we had to do some things with sandwiching VRFs in order to get these service functions stitched in. It worked. But as you can see from the diagram, it meant some artificial ability or artificial creation of VRFs. And then that was how I bumped the wire and inserted the service devices. Fast forward to now, and generally speaking, all of our service insertion logic is predicated on policy-based routing. It means that I can write VRFs in a more consistent and economical manner, and there's less of them, and it's more mapped to the best practices for how the network gets set up in the first place. And then the PBR function is going to essentially handle the reroute and say this protocol, these protocols, or this actual session needs to be sent to the firewall. Firewall is going to do what it does and then send it back to the fabric. The fabric will then go on and complete the operation. Any questions about what we've covered so far? I'm going to quickly cover integration to the public cloud, and then at that point, we're going to move to secure workload. But are there any questions about what I've covered? I know we're going fast, but as I said, we've got a lot of material to cover here. Okay, so let's talk about public cloud, right? Because public cloud obviously is something that I think fair to say the vast majority of our customers are now integrating, and we're seeing more and more workloads running in the public cloud. ACI has a manager of managers known as something called the NXOS Dashboard Orchestrator. And the NXOS Dashboard Orchestrator allows me to manage multiple ACI fabrics on premise. It also allows me to treat and manage additional public cloud-based workloads as an additional site. So we treat it just as another data center, albeit it's a rental data center where you're effectively using IaaS and PaaS services to facilitate attaching workloads. Now, as many of you may imagine, if we're going to in fact do this, I want to have the ability to still consistently generate and create policy and have it at a logic level be able to be instantiated in the public cloud. And how we do this is using something known as the Cloud APIC. And you see this kind of interesting looking icon here. That's what the Cloud APIC is. And the Cloud APIC is our policy converter. So I write or enumerate policy on-prem using the APICs, EPGs, contracts, all of that logic that we've spent the last 30 to 35 minutes explaining. And Cloud APIC effectively takes that ingress policy logic and it turns around and renders it into the native structures that the cloud providers use. Okay? So at that point, this is very consistent in the sense that I write policy, yet the cloud providers really have no understanding of what that is. They're using their own policy structures, and we just have a conversion tool. So the whole idea here is I have one tool that can consistently author and enumerate policy, private data centers, multi-cloud data centers, and out to the public cloud. Now, the other thing that is happening here, and I'll go to the next slide here, is we have some customers that favor the idea of today we place a Cat 8 KV, or more specifically a CSR, as our transit path where I build the overlay. Okay, so the overlay gets built between the private data center and the public cloud, and I use a router, and then Cloud APIC is doing my policy conversion. Some of our customers have told us that, listen, rather than using an additional Cisco component, I'd rather use the cloud native structures. Transit Gateway for Amazon, vWAN Hub for Azure, the Google Cloud Router for Google. So in this case, the only change I make is I write that policy, or the transit path is now an IP network using BGP and IPsec, and I'm going to natively manage and instantiate policy on the native cloud structures. Okay? I'll still render it in the native language that they take because Cloud APIC is here. Okay, so there's an additional layer of efficiency that happens as a result of this. We're going to continue to support both models. Either a Cisco transit device with Cloud APIC or the cloud native devices with a Cloud APIC to enumerate policy. And hopefully what you're taking out of this is one tool to write policy uniformly across public, private, and the alternate locations that you essentially have to drive policy to. Yes, sir.
How do you deal with services provided by Azure? As a service?
Sure. So how do we deal with services provided by Azure? Generally speaking, the answer to that is wherever possible, our attempt is to use the cloud native service that is there, an application load balancer, whatever that is. Customers obviously still, in a lot of cases, are going to want to use placement of their own types of devices. So if a cloud service exists, we generally will integrate and take APIs and manage it in that manner. If you tell me I want to place my own device in the public cloud in a VPC, in a VNet, or whatever that may be, you have freedom to do that, and we can still manage that.
The problem that we've had with those services is as soon as you spool up that service, it puts a /32 around every part of
Yeah.
your environment.
Yes. Yeah. So let's chat about that after. If you want to come on up, I'm happy to take that a little further here. So I want to spend the last 10 minutes on a technology that, as you kind of look at ACI, we have a tremendous amount of techniques to provide policy embedded into the fabric with L4 stateless controls, and also integrating the L4 through L7 service stitching devices. But there's a lot of situations where we look at this and say, if I want even further level of granular policy to control traffic, I may look to a workload or agent-based solution to provide that. And here we bring in something known as secure workload. And essentially this provides an ability for me to auto-discover workloads, map application dependencies, analyze and validate policy through simulation, enforce policy, and then also do all of the back-end compliance monitoring and audit control. And really what this is trying to do is provide a further reduction of the attack surface. It's also trying to more quickly allow you to lay very, very explicit and granular policy controls into the network. And then, we also have this notion of segmentation, while very appealing, is often a very time-consuming technique. Right? So we'd like to be able to provide value in, weeks or months, not years. And so how do we go about doing this? We use a set of agents that get installed into the workload at the bare metal, at the VM, or at the container level. And you get an idea here in terms of we support all of these types of operating systems where I can install and build agent relationships in the workloads. So that gives me very, very tight understanding of what the workloads are doing and how they're getting built. The agent itself is an extremely efficient, low overhead type of agent, right? It also is managed in the sense that it's highly secure, all code side and authenticated. The agent is responsible for collecting flow information. We don't collect any payload, and we don't do any sampling. So it is literally a visual depiction of everything going on the network on a per workload basis. Now, you might ask, okay, what if I've got other devices out there I want to collect telemetry information from? Load balancers, firewalls, additional NetFlow types of devices, types of devices running NAT and things of that nature. I apologize, I skipped too quickly. I have an ability to also ingest that information into the aggregate data lake. Okay, so Tetration or Secure Workload is a SaaS platform We use our own agents to ingest a lot of the information from the explicit workloads, but I can also bring in these additional sources of information to further enrich the data. Now, in trying to stay consistent with what we just talked about, we also have agents that can be installed in the cloud to be able to draw information from public cloud-based workloads as well. Because this would be incomplete if I didn't have the ability to also sample and ingest information from workloads that are running in the public cloud. So we take in VPC flow logs and a variety of things from public cloud types of workloads to further enrich that data source for the purposes of understanding how workloads are communicating with each other. Now, let's talk about how we actually build the application dependency maps. And there's actually a series of steps we're going to go through where we're going to take all those sources of telemetry and generate a baseline. Once we generate the baseline, we're going to have essentially the network operations security and other teams look at this and validate that the baseline that the AI/ML engine created is accurate. We're going to take into account multiple stakeholders in terms of saying this is the important things that have to be rendered for policy purposes. We also then are going to be able to leverage that agent for enforcement purposes, and I'm going to talk about how that gets done in a moment here. And then last, we have the ability to effectively consider and pay attention to all of the compliance, audit, and kind of risk reporting that most organizations are responsible for. Now, how do we do that? Essentially, we take all those respective sources of information, we run them into the SaaS platform, Secure Workload as a Service, and what that is going to output is essentially a picture or a visualization of how the application is communicating amongst the respective parts that represent the application. How the web front end is talking to the app server, how the app server is talking to the database server, how the application in total is talking to the rest of the world, and it's essentially going to build a map that says, listen, this application looks like this. This is how it communicates. This is what it is doing on a day-to-day basis. The nice thing here is there's no guesswork because I've literally taken all that information at an agent level so I can see 100% accurately what it's building. And out of that, it is going to create essentially a suggested baseline policy for you as a customer to implement. Now, how do I go about taking that baseline policy and turning it into enforcement? Right? Because policy is only as good as my ability to essentially take it and make it enforceable. And so tetration or secure workload, and I have a hard time kind of saying the new word because it used to be known as tetration, has got an ability for me to write that policy out to the network using the firewalls as enforcement devices. It can write it out to the agents that are already there. It can also write it out to the cloud assets. And we're illustrating some public cloud Kubernetes services here. So it's a complete picture of how I can write policy down to a very granular workload specific level. So you might ask, okay, where do I and don't I run policy here? Okay, because we've talked about you can run policy in the fabric, you can run policy on peripheral devices, i.e. firewalls. Now I've got a workload controlled or an endpoint system enumerating policy. The reason we named this session Defense in Depth is because generally our assertion is you need to run policy in probably all three of these locations to provide the most aggregate surface coverage possible. So you may look to use firewalls to manage north-south traffic. You may further use those firewalls via that service stitching function we talked about to manage east-west traffic flows, where you feel like the stateless policy logic built into something like ACI Fabric is insufficient. And then where I need to write extremely granular fine-grained control, where I need higher scale, I may look at a platform like Secure Workload to complement policy running in the fabric and running in the service complex devices. So an important concept to remember here is Secure Workload ingests a variety of information to enrich that kind of aggregate data set. And as I talked about, it writes micro-segmentation rules out to these agents, okay? And these agents are either in your on-premise workloads, VM, container, or bare metal, also in the cloud. It also can write policy out to firewalls. So the nice thing is I have one place to enumerate policy, and I can enrich that policy such that I can push it out to the firewall manager, and then the firewall manager can render it out to the respective physical devices. So the conclusion we reach here is, as I talked about at the outset, defense in depth is really kind of our best practices way of looking at policy and being able to essentially say, we want to reduce and control the attack surface in the best manner possible. And how do we do that? We're going to do that by combining the pre-existing use of firewalls. We're going to use firewalls in tandem with an ACI fabric where I can use L4 stateless controls and I can use the service stitching function, and then I can start providing workload-based, or what in a lot of cases is called zero trust functions, to complement that network and or security-based policy that comes from the firewall type devices. So with that, we are drawing to a close. I would typically spend some time saying, listen, go to additional sessions. We're winding down here, of course. So we've got, I think, one more session slot, and you've got lunch, and then people are probably going to be running for flights. As we've talked about all week, there's been a variety of opportunities for certification and other things here. And so with that, I appreciate you coming. As I said at the outset, the Teams room will be open until June 17th. So if you have any questions, if for some reason you have slide problems, please let me know. I will be happy to post them. Hopefully this was useful. The last thing I will tell you is I am a session group manager for Cisco Live, which means I help prepare and identify all the content. So we really, really value your feedback. We want to know what sessions are good, what content is good, what content we need to retire. So if at all possible, I encourage you to fill out your surveys. Provide honest feedback. What was good, what was bad, tell us what we need to do to improve, because we're always looking to make this better, and we always want to understand the sessions that we need to preserve because they're excellent. So with that, I will draw to a close, and I think we're right at time. We might be a minute or two over, but not much. So I appreciate everybody coming. Hopefully you've had a great week. Hopefully you found this session to be a useful exercise of your time. Okay.